Question 8. If theta is an angle in standard position and its terminal side passes through the point -4, -7, find the exact value of cosine theta in simplest radical form with a rational denominator. So I'm going to draw a coordinate plane, and they told me -4, -7, which is right there. So if I'm making an angle in standard position, this dot is going to connect to the origin, and this dot is also going to connect straight up to the x-axis. So there's the triangle we've created, and the angle we're going to be talking about is that angle there, the angle touching the origin and the closest x-axis. -4, -7 means we went to the left 4, so I'm going to label that -4, and down 7, so I'm going to label that -7. Now remember, technically triangles can have negative sides, but these are there to show me the direction they went, not the fact that I have a negative distance. So this question wants us to find the cosine. Cosine is adjacent over hypotenuse. So we have adjacent for this problem. The adjacent is -4. We don't have the hypotenuse, though. The hypotenuse is not given to us, so we have to calculate it using a squared plus b squared equals c squared. -4 squared plus -7 squared equals c squared. We have 16 plus 49 equals c squared. This adds up to 65. Does 65 simplify? Because I'm about to square root it. I mean, 65 is in the bottom. The square root of 65 in the bottom can't happen because it says make sure it has a rational denominator. But I'm wondering, does 65 have any perfect squares go into it? So 65 divided by 4 doesn't work. 65 divided by 9. 65 divided by 16. 65 divided by 25. 65 divided by 36. All right, I've gone all the way up to 64, so doesn't have any perfect squares that go into it, which means we're actually going to get to keep it as radical 65, which is nice. But we can't have a radical in the denominator, so to rationalize it, we multiply both the top and the bottom by radical 65. We get -4 radical 65 over, whoops, I'll write it again. -4 radical 65 over a regular 65, because when I multiply those, there's no radical anymore. Radical 65 times radical 65 is radical 65 squared, and radical and squared cancel. All right, so that is our answer. That's as far as we can go. So that's our answer to our cosine of theta. I'm going to double check here just to be sure. All right, looks good. All right, in quadrant 3, cosine is negative, and it is, so we did something right. Now time for part 2. Ted was asked what would happen if to the value of cosine theta if we move this point to 4, -7. So if we move this graph over here to 4, -7, Ted says, I think that if we move this point to 4, -7, the value of cosine would remain the same, since we would just create an equivalent triangle in a different quadrant. Okay, well, that seems right, because now my triangle is the same size and same direction, or same numbers. This is still going to be radical 65, just like this one was. Cosine of theta is adjacent over hypotenuse. So we're going to end up with, a very similar looking answer, but think about it. This 4 went to the right instead of the left. So now this 4 is not negative. This 4 is not negative. Our entire cosine answer is not negative anymore. And that's because in quadrant 4, cosine is positive. We've talked about how all students take calculus. And in this quadrant, cosine is positive. So this answer is different, and it would rationalize the same. It would still be 4 radical 65 over 65, but it's positive instead of negative. So we have to say Ted is incorrect. the values are the same, but it's positive instead of negative. And just in case we didn't justify it enough, let's just say this chart shows y. Let's just to be sure, let's say, hey, we know that in this quadrant cosine is positive and over here it was negative. Just to be on the safe side, let's make sure we justify it enough.